All right, welcome to our flipped classroom. So today what we're going to do is I'm going to kind of introduce you to slope criteria for parallel lines and for perpendicular lines, and that's going to set us up really well for the practice that we're going to do in class tomorrow. So what I'm going to do is I'm going to introduce the criteria, but the main point of the video is to actually prove it for you. We're only going to prove kind of one direction of these criteria, but hopefully it'll help you understand kind of where this is coming from so that we're not just memorizing it to memorize it. So the first criteria is for parallel lines. It says that two lines are parallel if and only if, so that means this goes in both directions, if and only if their slopes are equal and their y-intercepts are different. So today we're going to prove kind of one direction of this. So we're going to prove that if lines are parallel, the slopes are equal. And you can kind of infer that the other way would also be true. So the way we're going to do that is I'm going to take this diagram and I'm going to assume that these two lines are in fact parallel. So lines L and lines M are parallel. And I want to somehow show that that means that the slope of line L and the slope of line M are equal. Well, if you're looking at this diagram, hopefully you're seeing not only parallel lines, but some triangles here, right? We have triangle AOB, we have triangle COD, and maybe even some things like side-splitting theorem or proportional sides or triangle similarity are jumping to your brain. If so, excellent, because that is what we're going to use. So, thinking way back to when we learned about parallel lines for the first time, we learned a bunch of angle relationships, one being corresponding angles, right? So if we have lines that are parallel, we know that corresponding angles are congruent. So therefore, this angle here and this angle here would be congruent, right? I'm going to label these angles 1 and 2. And also, these two angles would be congruent at B and at D. And I'm going to label these 3 and 4. So I know just by those lines being parallel that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, right? And that's by corresponding angles postulate. Probably thought you'd never hear that again. Corresponding angles postulate. Okay. That again just says that if two lines are parallel, corresponding angles are congruent. So why do I care that these angles are congruent? Well, again, I said maybe you're seeing some triangles here. We have triangle AOB and triangle COD. And if I know that two of the angles are congruent in each of them, one of our triangle similarity criteria was angle-angle. So if I know those angles are congruent, I can actually conclude that triangle ABO is similar to triangle CDO by angle-angle triangle similarity. And that's going to help us figure out something about the slopes of these lines. Right. So just before we get into why triangle similarity works, I just want to take you back to what slope actually is. Slope is a ratio of rise over run, or change in y over change in x. So let's just think about what the slope of line L would be. Well, the slope of line L would be my rise here is going down this length, down AO, and then to the right, BO. So I could say that the slope of line L is in fact negative AO over BO. And if we think about the same thing for my line M, well, now I'm going down CO and right DO. So the slope of M would be negative CO over DO. Okay, this kind of looks like go, so I'm going to change it. Okay, so that's just based on rise over run. Rise, run. So could I prove that these proportions would be equal if I know that triangles are similar? Well, yes, and that's the whole part of the proof. So if these triangles are similar, that means that corresponding sides are proportional. So I could say, for instance, AO, right? Therefore, because they are similar, therefore AO over CO, those are two corresponding sides of these triangles. That proportion must be equal to BO over DO. And if you were to do some rearranging, cross multiply and redivide, this actually means that AO over BO is the same as CO over DO, which is exactly what I needed to show that these slopes are equal. If the positives are equal, the negatives of them would also be equal. So overall, these two slopes are equal, which is what we wanted to prove. And so this could be true for any two lines. We could use a similar argument, triangle similarity, to show that the side lengths of these triangles are proportional. Therefore, the slopes have the same proportion, which means they would be equal. So that's for parallel lines. Keep in mind, though, just to point out, the other part of this is that the y-intercepts have to be different. So for instance, like C and A are the y-intercepts here. They're clearly at different points. If, for instance, C and A were right on top of each other, this would no longer be two separate lines. It would just be one line. So that's kind of implied, but also very important to know that they're actually distinct lines. All right, moving on to perpendicular lines. So the perpendicular line criteria says that two lines are perpendicular if and only if their slopes are negative reciprocals of one another. It's a fancy term. Really what it means is the product of their slopes is -1. So let's dive in. So what we're going to do to prove this one is I'm going to say, here's my line. Okay, I've got some line going through the origin, 0, 0, and some point x, y. And I want to create a perpendicular line specifically by rotating this line 90 degrees clockwise about the origin. So way back, I think Q1 actually, we learned a bunch of coordinate rules for rotations. And our 90 degrees clockwise rule was that xy becomes y negative x when we rotate it 90 degrees clockwise. So if I were to apply that to this specific point, which I named xy because in general it could be any point on our grid, but on this grid particularly it's at 4, 5. So let's see where it would end up. So 4, 5 would rotate and land at 5, -4. So I can go over here, 1, 2, 3, 4, 5, down 4, and I'm going to label this y -x. Okay. And so I do in fact get a line now through the origin and this new point that I plotted. And if I extend it, you can see how it makes a 90-degree angle. It has to, right? Because we just rotated that whole line 90 degrees, making this a 90-degree angle. So these lines are perpendicular. Now what about their slopes? Well, the slope of this first line, I could just count, but because I want to talk about how it could be any point, let's use the x and y. So I want to remind you of something you learned in algebra, which was that between any 2 points, we can calculate the slope of a line by doing the change in y, which is y2 minus y1, divided by the change in x, or x2 minus x1. It's kind of a fancy way of saying rise over run. So for this first line, for my red line, which I'm going to label L, okay, so for the slope of line L, I could subtract my y coordinates and divide it by the subtraction of the x coordinates. So I'm going to do y minus 0 over x minus 0, which simplifies to y over x. Okay. And for my green line, which I will call W, why not? Okay. The slope of line W would be, well, now my y coordinate is -x, so it would be -x minus 0 over the x coordinate, which is y, minus 0, which is really just -x over y. So maybe you're seeing already what I meant by negative reciprocals. Well, y over x is positive, -x over y is negative. So one slope will always be positive, the other will be negative, and you can see that they're reciprocals. Y over x became x over y. And just to prove this last point, right, if we took those two slopes, y over x and -x over y, and multiplied them together, this would become -xy over +xy, which is really just -1. So perpendicular lines have negative reciprocal slopes. And so your last task is to answer these 2 questions on the back. Now remember that to compare slopes, you need them to be in slope-intercept form, which is y equals mx plus b. And that's really my only hint. So answer 1 and 2, we will go over them in class tomorrow. Good luck.